when I'm reading code, like I start the debugger, and then like I try to go through like how the path is going. So it's like start from CLI, and then it's
I
like there's
see.
Jack importer, and then
Yeah.
like it's calling the compiler with all the passes, and then it's
Yeah.
doing the so like I'm going through this debugger and
Yeah.
try to understand everything.
Yeah. Yeah.
Yeah, it's going. So I need some time to like get myself familiar with like
Of
how everything
course.
is working, and then like start working
Yeah.
on it.
Yeah. Yeah. 100%. Actually, that for understanding new code bases, that's like one of the best ways. Um,
Yeah.
so yeah, yeah. So like starting with the main functionality, the main critical path of functionality, like say running hello world.jack, like that would be like a really great way to kind of see the parts of the code base that are relevant, right? But there's a couple things that can so there's two parts when it comes to kind of understanding what's going on. There's really two parts, right? So you can go through the code base step by step like that. So that's really powerful tool for understanding the code base, but also understanding conceptually the architecture of the code base is useful, right? And so like for instance, if you're going through a compiler, like understanding that there's passes, understanding that there's a lowering from a high level representation to bytecode or machine code, like just understanding the conceptual concepts behind the code base is also super helpful. And those two things together like will accelerate your ability to understand, right? So I know you actually understand compilers, which so you understand the basics. But I can easily show you, like the like specifically to Jack, if it's useful, specifically Jack, what that
Yeah,
architecture looks
sure.
like. Is that a good place to start, or did you have a place you wanted to start?
Um,
Yeah,
no, no, no. I'm like at the middle of nowhere, so like
yeah.
whatever you start with, I'm good with that.
Okay, all right, good. So I think
Yeah.
ultimately, let me share my screen. Um,
Yeah.
let's see. So there's this diagram that I had Janica create a while back, and this is what it looks like. So there's this diagram of essentially like what's going on. It's kind of partially complete, right? It's not. This is a sketch. This is a conceptual sketch of what happens. So there's this parser, right? So we use a library called Lark, Lark, to be our parser generator. And so basically we'll generate the parser machinery, and then that will be kind of a part of the code base. But there's a particular function, and I'll show it to you, parser.py, that will illustrate how we go from using the Lark kind of like code, like the Lark,
So
yeah,
if
go ahead.
if I understand it correctly, like we have a log file, the Python will load the log file, and then it get the Jex string, and then convert that into some tree, like
Yeah,
AST kind of
exactly.
thing. So that's
Exactly.
the first step. Yeah.
Yeah, so that's the first step. And then there's a number of passes that execute, right? That makes changes to the AST or adds information or reorganizes it a bit. And then there's a pass that'll turn it into a Python AST. So it'll translate each node to a Python AST. Now, some of the nodes will not have a corresponding Python node, right? So something like add or function call, basic function call will have a corresponding Python node. But then there's some features of the language that won't have a corresponding Python node. So what those turn into are calls into the library that implements those features of Jack. So so if we have, let's say you have like an add operator, like of course Python has add, but if you have like a new kind of operator that Python doesn't have, that will be a function call that takes in the parameters that your add would. So much like you would have like add a, like so in Notepad I can say, um, let's get rid of this, let's get rid of that, let's make it bigger. If I so like your add operator in Python would turn into like you could reason about it as being an add, you know, source A, source B, right? And it returns, whatever the type is of source A and source B, right? Assuming those are the same types, but let's say it's ints, right? If I had a new kind of operator, let's call it, I don't know, question mark operator. Question mark could then be Q mark, source A and source B. So if the language has like to whatever, right? To whatever. So if the language introduces a new operator or a new kind of concept or functionality, those turn into calls, and this call would go into a library that implements all of that functionality, all the new functionality. Yeah,
And
questions.
so in the generated Python code,
Mm-hmm.
we are like importing some sort of a JEC runtime in that, right? To
Mm-hmm.
like
Yeah.
be able to use the question mark.
Yeah, exactly, exactly. So I mean, the way I drew it, so I usually like to draw these things organically, right? It's like, so if you have like, let's say this is a Python runtime, this is Python's runtime capabilities, right? You could almost imagine adding more runtime capabilities in the Jack, let's call it runtime. Okay? And so this Jack runtime extends Python. Now this is in pure C, now this is in pure Python, whatever, it actually doesn't matter. And then your program will run, typically actually, the way I like to draw this is your program might be here, and then your program, right? And so this is pure Jack program, geez, Jack program, and your program will use this RT, let's say the JRT. Let's just call it this. It's just for the concepts. It'll call this RT, or just use standard Python when only standard Python is being used. And so that's what enables the execution of your Jack program with its new capability. That's how we superset Python. So the supersetting really lives in here, and we directly execute out of one of these locations, where this is a library and this is the Python runtime. And this is a runtime library, you could think of it, right? So
But the user doesn't know the difference between we are using Python or we are using JEC runtime. So it's
exactly,
yeah.
exactly. And the Jack runtime, I mean, there's a number of like design principles and guidelines that were applied, right? Like, so this runtime is implemented without any kind of dependencies, any third-party dependencies, right? So everything is actually baked in. So it's a very thin layer
A
around
vendor
Python.
folder, right?
Yeah, so we have a vendor
Everything in the
folder.
vendor folder is our
Yeah, yep. And indeed, the vendor folder actually includes. I'd have to think if there's anything in the vendor folder. Yeah, like the type checking. That's kind of static analysis, right? So like, if we're talking about runtime world, basically, so you can think of this is another software component, right? So this is your program. This is your program. This is your runtime. So we can call this the runtime, right? This is the runtime. But then you also have your compiler, let's say, right? So you have your compiler here. Where do I put it? Yeah, let's put it inside compiler. Let me just reduce the sensitivity of the mouse to make it easier to draw. So you've got your compiler here, and so this is let's say this is the bytecode. This is bytecode, right? So this is bytecode. So this is bytecode, but then you have your Jack source that goes through the compiler, right? So you have your Jack source, right? That goes through the compiler. Let's do src. And the vendor folder actually vendors in much of these kinds of capabilities, right? So we vendor in the compiler. But ultimately, so this is at the package level of Jacklang. There's a rule that,
ah.
yeah, your core Jacklang,
It
your
doesn't
core
have any
Jacklang,
runtime dependency.
it can't have any dependencies because you wouldn't want Jack to collide with anything a user might do or want to or want to, like you don't want to have package collisions and so forth. So it's got to be one
Um,
self-contained, you know.
okay, one question.
Mm.
So let's say we produce the bytecode like PYC, right, from Jack source code,
Mm-hmm.
and then say I'm only shipping that PYC to someone else. It's say it's a very simple hello world, but it also has the question mark operator. So we also need to ship the Jack runtime, or like the Jack runtime is also like put in the module of the PYC file.
Yep.
Is Do we need a separate? Okay.
So basically, like just to kind of understand the flow, in order to either use or run Jack, you have to do a pip install jacklang, right? So whether you're either using it to create programs or running programs, so it's a lot like Python, right? You can almost, even though we have this compiler and all that, you can kind of engage it as, you're running Python code, right? Like so in order to use it, you need to have jacklang. Now the runtime is included in jacklang, and the compiler is included in jacklang.
Like I'm thinking in terms of Java. Like Java, the compiler runtime are like and then you compile from it, and then you get percentage. Oh, and one the most important problem with Python is that Java, they like provide a specification to their bytecode. So if you compile one page, you can write wherever you want. But Python bytecodes are not standardized, so like it will change everything. So you have to have the compiler and runtime at the same time, and then you have to
Yeah,
do it.
yeah.
That makes sense. Yeah.
Yeah. And actually, so I've thought about this a bit, right? So, and I think that there is a roadmap for creating something a little bit more standard and stable. So, like, there is a roadmap where you can have this. There's a so yeah. So I mean, that's a very interesting point, and there's actually design flexibility because the fact that we have and this is kind of off topic, so I don't want to just kind of distract you so much. But the fact that we have this self-contained Jack ASD, you can actually create a little bit more portable of a situation at this level. And because, to your point, this level and this level is always going to move with the development of Python. And so I've got thoughts, man. I've got thoughts as to things we can do to create standardized stuff, that's a little bit more portable.
LLVM IR. So like whatever language, for example, you can compile JavaScript to Jclang if you standardize our IR,
Yeah.
like Jack IR or something, and then you can
Yeah.
run anything to any
Yeah.
code base.
Yeah,
Yeah.
yeah, totally. And another little side point I'll mention is, so a lot of people will say, oh, well, you can't, because you have a standardized spec that's well maintained of the JVM, the Java bytecode, then it makes it a good target to set as your compile target, right? Because it's a standard bytecode that's portable, right? So there's that story. In actuality, and I want to put this in a study, indeed, if you look at how rapidly, the bytecode specification for Python changes year over year,
Yeah.
it's not that much more rapid than, say, Java's updated specs. It's not that much more rapid, and it's just not it's not presented as a spec. It's not presented as a it's really about the packaging and the marketing of the bytecode. So I'm not sure I've not been super convinced that Python bytecode isn't a good target for portable backends, right? So I mean, and it's really just a question as to how rapidly does that bytecode spec change. And yes, Python changes more rapidly, but it's slowing down, right? And it's it's not the thing is they don't version it well, they kind of, I don't know, right? It's a debate. Yeah.
I mean, the pickle inside the pickle, they have everything. Like they already have, okay, this bytecode, this version will support this version of
Exactly.
this, all those kind of things. They already have it, but
Yeah.
it's not like, okay, it's our internal stuff. Now we are not encouraging others to use it, but
Yeah.
it doesn't matter. Like if we can use it, if it works, then
Exactly.
That's the end of
Exactly.
the story.
Yeah. And I think why they do that, and this is a really good discussion. I think why they do that is because they want the freedom to do breaking changes at that level,
Yeah.
right? So they want the freedom to be able to clean up design choices. It's actually kind of clever because when you look at the backward compatibility requirement of say JavaScript or Java itself, any bad decisions you get stuck with for a very long time. You have this long deprecation cycles and so
Uh,
forth. And so like it really just gives the Python team a little bit more freedom to be nimble. But I don't know. I think it'd be interesting to really study how many times were there breaking changes?
like
How many
there is
times there? Yeah.
there is also like the Python, they only say, okay, this is our syntax. If you want to make a compiler, make it. Like only the C Python has reference counting. There's another Python. I'm not sure what's the implementation, but they are using some sort of a garbage collection. So they don't even have the bytecode that they generated doesn't even have a lot of like global lock or something. So
Yeah. Yeah.
like
Exactly.
it's not even a standard. Like C Python is one version of the Python
Yeah,
interpreter.
exactly, dude. Like, so it's super interesting, right? It's like from that perspective. Anyway, like the cool thing is this thing is pretty like it's pretty interesting. So okay, so we were at what PyAST. Okay, so then you have the PyAST, and so this is what this part means, right? It basically means that you have where did I put it? Oh, here it is. It basically means you have like this kind of design, right? Now, and then vendor does a lot of stuff here. This is kind of implemented very cleanly, minimally, and purely, and you'll get to kind of become more familiar with what this looks like. I might actually do some repo like package renaming so that I could actually name these things in a way that's more sensible because this is actually called core. Ooh, wrong thing. This is actually called core in the code base. It's actually the core directory, but I really should just call it the Jack runtime lib. Jack RT lib
Yeah,
would be better,
I'm also
right?
like, yeah, like RT or something will make more sense. Like
Yeah.
it does the importer. The importer is inside the core. Like I want to like think the core is like the compiler and that like if you want to convert to Python to Jack or something, those kind of things are core and then runtime is
Yeah.
completely different.
Exactly, 100%. So you're absolutely right. You're absolutely right. Like, but importer, you're like that's a great example. So importer replaces or supersets, let's say Python's native importer, which is actually just a function. It's by the way, Python was designed so beautifully. It's actually, I mean, when it comes to the flexibility and the introspection and the
Yeah.
presentation of all of its internals as standard library, like it's actually really, really one of a kind. I've never seen anything
Like
like it.
there is no other language that has the flexibility of Python. Like you, in the runtime, you can generate a source code, you can compile it, you
Yeah,
get the bytecode, and you can run it. Like in
yeah,
Python, there's
yeah,
no other language
yeah,
can do this. And the
exactly.
fact that Python is very old language, like even Python comes before Java,
Yeah, yeah,
so
I
that's
know. I know. It's really
that's
impressive. That's why look, honestly, like great design like that is what explains why it's so successful, right? And so Guido is probably underrated. The inventor of Python. He's underrated as a intellect and for his
one resume.
contribution, right? From an intellectual standpoint, like there's no papers about Python's design. You know what I mean? Which is unfortunate, right? Because it's really quite an impressive um, an impressive piece of work. So okay, so the the cool thing is after we have that PyAST, oh wait, after we have that PyAST, um, we have we do this we do a number of static analyses, right? Which includes this type type checking. And so type checking is done by MyPy directly, right? So inside of that compiler, one of these is MyPy, right? So one of these is MyPy
That's
directly.
also part of a parser, right? My passes my py or something. My py passes.
Yeah, yeah, yeah. Well, the
Oh,
thing is, we bypass the parsing of my. Well, yeah, we bypass the parse. Well, I guess you can't say that. So the input into
okay.
MyPy,
I never
MyPy is
okay.
the AST. So we input the so once we actually don't give it source, we give it AST nodes. So MyPy works directly off the AST of Python. The but it actually generates its own AST nodes too. There's MyPy AST nodes, and that it uses that as a different AST than Python's native AST, which is very interesting. Um,
Wait, so we also generate the Python's AST before we do anything of this.
yeah,
Or like, how do we make
exactly.
sure?
Yeah, yeah. We generate the Python AST
Uh,
like first. So first we just organize the Jack code, the Jack AST. We do a couple analyses on it, little transformations, and then with the Python AST, we put that into MyPy, and then we let MyPy check it. Now the cool thing about this link, let me see. Oh, I got to use this one. The cool thing about this link, right, is that these nodes, when you create it, when you construct it and generate it, you can specify the line numbers and column numbers and so forth. So, as I mentioned previously, like these nodes think that they're in a Jack file, which is really interesting. All of their information links back to the source information, links back to a Jack file, which is cool. But they're proper Python nodes, so MyPy type checks it perfectly. And then we literally send that type information back to the corresponding Jack nodes. So this Jack AST is then updated with the same type information that's lifted from the MyPy information, and that works really beautifully. And then this step is optional, actually. Like you can go straight from here to bytecode code gen, and we don't do anything fancy here right now, but we can. We can. That's like future roadmap. Fancy stuff here is future roadmap, but right now we just go into a native Python bytecode, and then we run it on the Python interpreter, right? That has like, the Jack interpreter here as runtime here. So this is kind of the architecture of Jack. You know.
like, yeah, it's super, like, very overview. Like, I need to get into the,
Yeah,
like,
yeah, of course.
every bits and pieces of it together.
Sure. So what I'm gonna do next is
I think I got it.
yeah, like let me just
Yeah.
take you through some of the code, right? And maybe some of the code you've watched, you've seen. Hold on. So what time is it? Okay. So let's see. All right. So oh man. See, my microphone automatically makes itself lower. It's very frustrating. So have you heard my volume change?
Oh, okay. Makes sense.
Yeah, yeah, yeah. Like it just
Uh,
change. Yeah, it just changes its volume. It's super annoying. Um, okay, so let's see. So I think we'll start. Well, you started with CLI, right? Yeah. So like Jack Run. So you started with like Jack Run, like here, and then you noticed. Okay, so some of this stuff, like, I guess you see the thing is there's multiple areas that you can become familiar with. I guess you want to do like a top down, understand the whole thing, and then depth instead of what a lot of folks on the
yeah,
team has done. They've started with one small like
bottom up.
area and then worked in there and then kind of popped up. But maybe a top down is better. I actually there's challenges with bottom up for sure. So maybe
Yeah.
top down is
No, it's
better.
like if you read a book, you read the context, table of context, and you understand, okay, these are the things, and
Yeah.
then you go into particular area and then you
Okay.
read it.
Yeah.
You come
Yeah.
back, you go to another area. So it's like you
Exactly.
understand what is this book about.
Exactly. Exactly. Yeah, that makes sense. So this Jack context thing, this is okay. So we'll talk about the plugin interface. So one of the key design decisions that was made is a microkernel. A lot of this comes from the learnings from Jack One, from Joseki One. This is designed. This whole thing is designed to be a microkernel. The way I'm going to draw this, I guess, is I'll use a different color, and then I'll just say,
Your screen is not here at the
oh,
moment.
oh, oh, how did that happen? Oh, sorry.
No, no, it's
Oh,
like a
yeah.
couple of minutes ago.
Oh, I see. Oh, wow. Okay. So, so this is actually a microkernel design, is what I call it. That's a operating systems term that means there's a core, and then let me make. How do I make this bigger? Brush size. This thing. Brushes. Brush. Okay, that's bigger. There's a core, right? And then there's a plugin interface around the core, right? So this plugin interface lets you replace any of the functionality or superset any of certain functionality. This is actually how we implement Joseki, and we'll talk about Joseki at some point. But so this plugin, so almost everything in this layer can be replaced with your own functionality via plugins. There's a relatively robust plugin interface, right? So you can almost create plugins to replace many little pieces of the implementation. Now,
Oh, so
yeah,
Python is not like tightly coupled. You can take the Python and then you can put some other language also as a main runtime.
yeah. Well,
If that
well,
makes sense.
yeah. Well, and it's certain features. So this is an evolving thing, right? So certain capabilities. So like basically, there's functionality of all the Jack. Um, Let me think about how I
Right.
describe this. So, all right, let's just put it like this. When you look at the code, there's this plugins directory. This plugin directory, this specified the plugin interface. It really should be called plugin interface. And then this is using, PyTest, how like you could just do pip install PyTest, and then you can just pip install PyTest xdist, and then all of a sudden PyTest now has new command line options, and then you can pip install some other
Yeah.
PyTest. Same with Flake8, right? You Flake8, pip install whatever, pip install whatever. It uses an interface called Pluggy. This is also vendored in there. It uses a plugin interface called Pluggy. That's kind of the PyTest plugin interface. This also uses Pluggy. So basically, you can simply pip install jacklang dash whatever, and then it instantly is present in jacklang in the order of which it was installed. I don't know if you're
Right.
familiar with this. Yeah.
So, okay, I understand. For example, let's say our checkline doesn't have any type checking, and then someone else make their own type checking, and then they want to implement it inside our AST passes, so they can plug it in our their type checking inside our thing, and then
100%. That's exactly right. That's exactly right. If someone wants to replace the testing approach, like, because we have a keyword for test and check. If someone was like, well, I don't like PyTest, I want to use my test, or I don't like unit test, I want to use PyTest, they can write their own plugin and replace that entire functionality. And so, and
wow,
so that's present in this folder, right? Has these interfaces that expose the replaceable elements, right? So in spec here, like, we have like creating the object, creating the node, creating the edge, creating a walker. That's the Jack stuff. You can write your own importer if you wanted. You can write your own test. Run test. How would the test is run? The Elvis operator. This is just for example. Of course, no one's going to change the behavior of an Elvis operator, but there's a number of these that you can kind of write your own behavior or add your own behavior to, right? So, there's a number of examples of plugins being built, but we have this plugin interface, and so some of the
it makes sense.
functionality,
Like,
yeah, some of the functionality like
yeah,
this
sorry,
content.
I
Go
really
ahead.
have a bad habit of like interrupting people when they talk.
Go
Like,
no, go
I
ahead. No,
really
that's
have to
good.
improve that.
No, no, it's not. It's not a bad
No,
habit. Like,
I'm
good. Yeah, yeah.
no, I'm just reading the code and I was really confused why the importer is inside the features of plugins area. So this really makes sense now. So
Yeah, for
yeah,
sure,
you
for
go.
sure. And this context goes to the plugin, and whenever you see a feature, you should, and this PM hook, the defaults is where it's all implemented, right? Default.py is where you have the actual implementation. So context really is implemented here, and there's a notion of an execution context. You don't have to worry about this right now. This is because Jack Lang lets you seamlessly like make your graphs persistent in a database, like a MongoDB if you want. Or like, so basically when you're building a graph, it'll automatically organize itself in a MongoDB and stays persistence overruns if you want it. So that's not going to be in this code base. That's in the Giseki code base. But this is a hook so that Giseki can, you can do pip install Giseki, and all of a sudden, when you're creating these graphs off of the root node, they're persisting in a database. And so you can, ultimately, you can write a simple Jack program and then just not change the program, run it in the cloud, and it becomes a scalable microservice. So that's how we achieve that,
Okay.
which is one of the big classes of features that this language enables. It's actually what motivated the language.
Sounds like super impressive, but like I
Yeah,
want to
yeah. But
check it from all side, yeah.
I wouldn't worry about that at the moment. You'll learn that over time. This is a fire hose of stuff, right? So, but if we go to Jack Run here, if we go to Jack Run, so you don't have to worry about this. This isn't actually necessary to run the program. It's just a hook. But you got to where this Jack import, right? And so this Jack import is really where the magic starts. And this will ultimately take you to, from default, you probably went there already, to importer, from default to importer.
Oh, and the question, there is include and there is import, right? I don't
Yeah.
understand the difference.
Yeah, the difference from a semantic standpoint is include is exactly the same as from blah import star. That's it.
Uh, oh,
Yeah,
it's like the preprocessor in C or C++. Like it
exactly.
just copy the source code and put
Yeah,
everything here.
yeah.
Okay.
Yeah, it's kind of like that, but it really is a module thing. It basically is just, I think, is better
Import
syntax
all the
for,
symbols.
it's just better
Import.
syntax for that. So it's include blah,
Oh, more of a
right?
syntax sugar for. Okay.
Yeah, it's syntax sugar for that, but really it was in the first implementation. You know how you could separate implementations from, yeah,
Yeah.
it it was for that. So it also does that, right? So if you have your implementations, now this is kind of at this stage of the language, there was a time where it wasn't automatic. We created naming conventions where module name.impl.jack automatically is ingested. So that came later, but initially it was you had to do something like this to bring it in. And so we have it's syntax sugar, dude. It's just syntax sugar for this.
Yeah.
Yeah, yeah, that's all.
Yeah.
So
Okay.
and then so Jack importer. Now so then you get to compile, right? And then when you go to compile, so this is all very complicated because this has to, one of the requirements is that we faithfully mimic the semantics of Python, and we can go beyond the semantics, but we can't not support certain semantics. So this is a very complicated thing, but I wouldn't worry too much about this now. This is actually still in development. I mean, it works, but it's dirty, and we need to make it cleaner and simpler. But let's see. But really, there's the compile. Basically, compile jack is called. So if you just get the clean source file, this will call compile jack, right? And that's where the compilation happens. And there's a set of these functions, compile functions. This could also be cleaned up and refactored to be a better architecture of code, but we just have a set of these compile functions that ultimately hits this kind of pattern. So this is kind of the straight compile pattern where we take the file, oh well, whatever. It gets the source code from the file. So it creates this Jack source ASC node, which will just be the source code from the file. And then It always parses first. This is why it's not in the schedule. So if you notice, the schedule never has jack parser. Oh, this one. So it
Oh,
take yeah.
there is no pass that takes the string and then convert into AST.
Yeah.
Is that
That's this one. That's this one. This one's just baked into the. So we
uh,
could
it's
we could put this
it's
one
not
over
part of the
here.
schedule.
Yeah. We could put it over here in principle, but being that to even get started, you need to do that all the time is get the AST. I
Yeah.
just made it. I made it baked in, and then after you have AST ret, which is the AST for I in schedule, whatever your schedule is, up until your target, right? You can specify like a target. You can specify a stop point, right? So this is almost like when to stop. See, we should call this. I'll rename these because I realize we should have great names for all of these things. But so this is the stop point. But it'll just say, and I shouldn't use I. Like I should just turn this into for next pass,
The
next
pass.
pass in schedule.
Yeah, next pass.
You run the ASD. It just runs the next pass on the IR from the previous pass. And then it'll do your target, which will end up being the last one if there's not a target. So it'll do the target and then return that AST ret.
Question. So, for example, our type checking plugin example, right? So, if I implement my own type checking, then I will put it as a pass inside this scheduler. It's something different.
Yeah.
It's not like
Yeah, exactly. So you basically just overwrite. This is the type check schedule, which does jack type check pass. Essentially, you'd have an entry point that replaces this, right? And the thing is, so the process of adding something new so there's a couple, and maybe this is a good thing in the plugin interface. Instead of we there may be some small edits to the plugin interface you'd want to do for specifically for type checking. It should be like 10 lines of code to then make the plugin interface manage the type check schedule. But yeah, this is what you would change. You'd essentially just change the schedule of any pass, right? So then these would be, so basically in order to hook these into the plugin interface, you would have this be in default. You'd have these in default, and then these variables would load it through that features jack feature dot get pass, get schedule, right? So you'd have like a get schedule instead of using the schedule directly here, right? And so basically you
and
would
then we
move
can
this
customize
to
the
default.
schedule with the plugin.
Exactly. Then you can control it
Yeah.
with the plugin. Yeah. So yeah, and so we're continuing to like expand on the plugin interface as we go, and it's very simple to move certain functionality into the plugin interface. Yeah, man. So okay, so that's the schedule. So that's how we get to the schedules, and then each one of these has a different purpose. I think that's good, right? This one, PyAST GenPass is the one that we generate. I know it's a fire hose. So this is kind of the most interesting pass. There's a couple places. What I should do is I should give you a couple potential areas you'd want to dig deep on. Tell me what your strengths are, or what you think it would be an interesting area that you might want to look at.
Yeah, the AST stuff, the parser stuff, or the parsers. Maybe I can work on the plugins too. But uh, like, what are the
Yeah,
options? Like, what are the
yeah.
things that you would say I would focus on?
Yeah. So, I mean, on the roadmap, so we have a number of things on the roadmap. I'm thinking of like a small project that would be kind of fun. Is that one that I talked about yesterday, where it's like take check and then have it automatically detect the assert the right asserts to put based on the structure of the AST. Um, I mean, that might be a heavy lift. I mean, I can also imagine like let's just create a plugin, right? Like because there are these standard plugins that we want to support. So PyTest, Poetry, like we need a JIP, like it's like pip, but a JIP, right? We need a JIP, and JIP is just gonna be poetry. It's gonna be poetry overloaded, right? So I mean, one interesting thing is if you look at so in the vendor directory. I'll think about it too, but in the vendor, where is it? In the vendor directory, we have like MyPy. MyPy is unedited, so all of these are unedited, so it's easy to upgrade. So they're untouched, but we had to really reverse engineer functionality into MyPy, and we did that by overriding certain things. So basically, how we do that is this is going to look messy. MyPy, where is it? MyPy AST build. Yeah, MyPy AST build. So here, we'll actually import not directly from MyPy, but we'll import from this file that lives inside of the Jacklang codebase. It's not in the vendor directory. And this file just pulls a bunch of stuff from MyPy that we want to add our own functionality to. So we override certain parts of MyPy to have like our own functionality that we need to be able to turn MyPy into our type checker. So it's kind of clever how this works. It's yeah, well
Wait, so
because
if my
yeah, go
pipe
ahead.
changes something, it will break, right?
No, that's the thing. Here's the thing. What happens is it can, of course, you can break if I mean, they could break stuff once they change their code base, but in practice, it doesn't break, right? So when you directly make changes to MyPy's code, upgrading is incredibly difficult.
Yeah.
But if you keep MyPy's code silo and you just you cherry pick the functions that you override, then upgrading becomes easy. And most of the time, upgrade doesn't break functionality most of the time because
Oh, this is really clever. Like,
yeah yeah yeah
yeah.
yeah exactly.
Uh,
So I think taking poetry, we can do the same thing, right? And then we can create our own JIP out of poetry.
uh, okay, so I'm not familiar with poetry, so it's like a package management thing, right?
Exactly. It's really
For
a wrapper
Python.
around pip. It's really a
Oh,
yeah. It's like a super pip. Um, so I think that's what, so like PyTest is also a third party. So anything that's in third party land as a general design choice and policy, um, anything that's third party land, like the core here uses unit test, right? For the test check functionality, right? But unit test is kind of lame compared to PyTest. And so we're going to create a plugin. So anything that wants to depend on a third party, we can create a plugin and upgrade it, right? So we can actually create a jacklang-pytest that will replace unit test for tests with PyTest. And then we're going to create a JIP. And the JIP core is probably going to be pip, pip based. But we're going to create a plugin so we can have a poetry based one, right? That's standard supported by Jaseki. Now, if you want to use, because poetry has competitors, if you want to use a poetry competitor, just write your own plugin and then just replace
plugin.
it. Yeah, exactly.
Wow.
Yeah, 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 man.
Wow.
Okay,
It has
yeah.
every single language features that like it supports everything, right?
Exactly,
Wow, this is
exactly. It
amazing.
supports the entire Python ecosystem. We just can easily benefit. This was one of the, because in Jack 1 it wasn't like that. You'd have to rebuild everything, which is insane amounts of
And
work. But this is
like
yeah.
again. So like I bet you didn't like plan to create like a debugger support or anything to Jekyll.
Exactly.
But the fact that we
Exactly.
can like one-to-one mapping between the Jekyll and the bytecode, I can just debug inside the Jek file, and like I'm really
Exactly.
mind blowing when I do that.
Exactly.
So,
Exactly. 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 And so PDB works out of the box with Jacklang because PDB can work off of the bytecode or the AST, and then you can map it because all of the AST nodes thinks it's from that source line in
fine.
Jack, right? The source file in Jack.
Yeah.
So it's pretty crazy, dude. Um, but I've got to run, dude. So let's do this again.
Yeah.
We'll do this again in a couple, maybe 2, 3 days or so, and we'll just catch up. And then we'll find a project after you tinker a bit more and experiment.
Yeah.
There's also there's the VS Code extension, the language server. The language server is baked
Yeah,
in.
I already set up everything.
Oh yeah,
Yeah.
good, good.
I have
And
already set up this.
yeah,
Yeah.
yeah. That's good.
But
It's
I'm more of a Vim user, so there is a Vim repo in there, but I don't see how to set up anything.
Yeah, we'll talk about
More
that
of a,
because
yeah.
if you're using NeoVim, which is awesome, I love it. If you're using NeoVim, the LSP, the language server provider, is where the entire extension is implemented, and it's built into Jack.
Oh,
So if you do Jack
everything,
LSP,
right?
that's the server provider. We'll talk about that next time. But
Oh,
yeah,
okay.
yeah.
Yeah.
Yeah. So
That would
yeah,
be,
man. All
yeah.
right, cool. It's so good to chat with you. Can't wait. Good luck, and I'll talk to you in 2 days, man.
Actually, and thanks for this time, man. Like
Oh, of
it's really
course.
worth it.
Yeah,
And
yeah, yeah,
thanks for
yeah.
your time.
Yeah,
Okay.
anytime, anytime. I look forward to the next one. Cool. Yep.
Yeah, me
Awesome.
too. Have a
Yeah.
great day, man.
Yeah,
Okay,
you
bye.
too. Yeah, bye.